The JavaScript ecosystem has thousands of interactive web components for displaying beautiful charts, clickable grid of images, video streaming from the webcam, animated graphics, and any of those components could be integrated in my Streamlit app. I would know I built 3 popular ones. For example, let me integrate a clickable Plotly Chart in my Streamlit app, which will return the coordinates of any data points I clicked on back into Streamlit. Let me create a new folder next to my Streamlit script. It will contain the web component frontend code. Add an init script to make this folder an accessible Python package. Write down a new Plotly events method, which takes a Plotly figure as input and returns none for now. I can now import the Plotly events method into my Streamlit script. This acts as the Python entry point for the embedded clickable Plotly chart. Now, how do I get my Python code to embed the HTML and JavaScript frontend code, which returns values back into my Streamlit app? Download the Streamlit component lib file into the frontend folder. This contains all the JavaScript code that sends and receives messages between the Python code and the embedded frontend component. I also download the Plotly minified JavaScript file into the folder. It kinda looks like code, but it's a bit hard to read. But no worries, this is because this file was compressed by removing all white space, renaming variables to short names, make it very light and easy to download at the expense of human readability. Oh, did you know that Plotly is actually a JavaScript library with a Python API? And Altair is the same with Vega, PyEcharts is the same with eCharts. The truth is, Python is only a frontend for JavaScript. Create a new index.html file. Add an HTML tag with a head and a body section. For now, just remember the head section contains all metadata and is the best place to import and run any JavaScript files. I could actually download the Plotly files from the CDN instead, since they are minified and my browser should cache them after some downloads. But if I'm running my code in a building where there is no connection, no Stack Overflow, and I cannot download the files live in a demonstration to the CEO of the company, I'd be in very deep trouble. So might as well pre-download the necessary files. Finally, create an index.js file, import it into index.html. This JS file will contain all the component logic. Import it after the others. It will use the methods from the other 2 scripts. Add a div with a specific ID into the body section. This will be manipulated later by the index.js file to inject some Plotly charts. Let's head back to the init.py file. How do I get Streamlit to call this index.html when Plotly events is called? This is where I shall declare this folder as Streamlit Component. Why am I doing this? I declare the current Plotly folder as a component internally named Plotly events and store the resulting function in a component func variable. Whenever I call it with arguments, it will pass those in a special JavaScript event that I can catch in the index.js file thanks to all the plumbing that was done in the Streamlit component lib file. Note that if you pass a Python dictionary as argument to this function, it will be transferred as JSON into the front-end part, and you actually have a lot of libraries in JavaScript that take as input a JSON. Plotly does, Vega does, eCharts does, a lot of libraries do. Now is the time to convert the Plotly figure to a dictionary using the doJSON method. We are cheating a little bit here. ToJSON returns a string of the JSON because the dictionary contains NumPy data which are declared components, cannot actually serialize. I now send the specification as input to the declared comp. Okay, write a default value of none, which will act as the placeholder result out of the component, and then return the result of the component back to Python. This component value will soon contain the information of the clicked data points. Back into our index.js file, create an onData from Python function. Since this function reacts to events, I link it to the Streamlit events add event listener to react to a Streamlit render event. Then I call Streamlit set component ready to open up the door to events sent from Python. I store a reference to our div with the specific ID we used. The arguments from the Python call are stored in the event.detail. Therefore, I extract our Plotly chart specification as a string from there and then resurrect it back into JSON. Do you remember, by the way, from my previous videos, who's our best friend in the front-end world? If I add a console log spec to print the JSON into the DevTools console, I can make sure everything is connected because it should be printed there. If it appears first try, then congratulations! I can change the Plotly Express chart now in my script and save to rerun. The specification in the console should update just like for a normal Streamlit widget. Link that JSON specification to the div reference using the Plotly new plot object, then set the height of the frame that contains your component. Look at this beautiful Plotly chart. Finally, I capture the Plotly click event on the div reference and create an anonymous function that maps all event data into a set of x and y coordinates. I eventually use the Streamlit set component value to send back the data to Python in the component value result of the component. We are lucky that Plotly comes with all of its dependencies bundled into the file, but what if you want to rely on multiple JavaScript components? We don't want to go and download all of the files one by one, and it's not going to be very maintainable. How do you update the version of a file? How do you make sure that this doesn't conflict with other versions of other files? This is a mess, and this is where you need a JavaScript package manager. 8 years ago, I had to implement a full web app in a week to display a machine learning demo where one would draw something on a canvas, a model would return an object prediction, and then you could ask for user feedback to retrain that model. I used Flask as a Python backend server, hosting the model and serving prediction through an API. And for the front end, I did not keep a pleasant memory of this learning experience. There were so many things that were unclear for me at this time. Do I need a bundler? How do I write good HTML? Do I need a CSS preprocessor? Which JS framework should I use? Routing, event management, error handling, all of this in a week. It was a terrible grind. But I didn't have to learn all of this to integrate my web components into Streamlit. Streamlit takes care of all the harder parts of the JavaScript ecosystem, like the routing, the event management, and the logging, and etc. And if you're able to manage the smaller JavaScript scope of importing JS libraries into Streamlit, then you will have a huge advantage over data scientists that can only export matplotlib plots into PowerPoint slides. The only prerequisite I need for the next section is npm and node.js. npm is like the PyPy of JavaScript. All JS libraries are certainly on npm. npm runs with the node.js language, so I need node.js. I personally used the node.js installer as it both installed npm and node.js for me. Next, I isolate the front-end code from the Python file by putting the HTML and JavaScript files into a new front-end source folder. I get rid of the Plotly and Streamlit scripts. Those will now be managed by npm. Run npm init inside the front-end folder. Answer the questions, and don't worry if you mess this up. This only creates a new package.json file that you can edit manually later. This package.json file is the most important thing inside your front-end folder. It is where one lists all required dependencies and scripts to run your JavaScript project. Contrary to Python, where I need to put all of the dependencies manually in a requirements.dex file, with npm I can install the dependencies and add them to package.json with one single command. With this tip, I installed Plotly and Streamlit Component.js. The two packages appear inside package.json, and a new node modules folder should appear in my project. Dependencies are managed at project level in npm. This node modules is tied to this project and only used when I work in this folder. Feel free to delete the folder and reinstall the dependencies by rerunning npm install, which will read all dependencies from package.json. Oh, don't forget to add node modules to gitignore. You don't want to push all of the dependencies to GitHub. There are some small edits to bring to our HTML and JavaScript source files. I first bring out index.html to remove all of the JavaScript imports and that hard-coded div. The only thing that should be left is importing index.js in the body as a module. Let's go to our JavaScript file. Because I removed the div from index.html, I will instead create that div block in JavaScript and reference it at the same time. And I want to test something new, so I also changed the syntax for declaring the function into an arrow function. It's actually very similar to a Python lambda function if you blink your eyes very quickly. Finally, I import Plotly and Streamlit, and that's it, the code is done. Now if I try to run it this way, when my browser receives this index.html file, it doesn't know how to resolve the imports and the dependencies. It has no knowledge of the node modules files that are residing on the server. We need a piece of software that is able to resolve the dependencies for us and then bundle and minify all the JavaScript files together into one that our Streamlit declare component is then able to use just like last time. There are loads of bundlers and minifiers, so the simplest one I found is Parcel. Let's install it as a development dependencies with npm. You don't need to bring this into production. I add some new scripts in package.json to call Parcel in specific ways. Now run the npm run build command to build a production-ready HTML and JavaScript file inside the build folder that you should reference in your init file. Henceforth, you can now run your Streamlit script with your new component. You may have noticed I need to rebuild the HTML and JS files whenever I edit the source files or update the dependencies.
Which is a slower process.
What if I told you there's a way with Parcel to start a web server that would build and serve your front-end code in real time? In another console, go back to your front-end folder and run npm run dev to start a Parcel server that delivers the built front-end files over localhost. In your init file, create a new boolean flag to pass to true when you want to use the Parcel server and then false to use the build folder. Now, just like when I develop in Streamlit, I'm free to edit the front-end code and see the results immediately over my app. If you finish this part, you can proudly say in the comments that you're a front-end developer. You've got the necessary skills to import any JavaScript library from npm into your Streamlit app. To use front-end code? Is that possible for a data scientist? React and TypeScript are currently leading the way of modern JavaScript development. React is one of the leading JavaScript frameworks. It provides a structured way to build interactive web user interfaces, and a lot of NPM packages now have a React version that takes care of some boilerplate for you. And TypeScript? You know how Python have type hints? But apart from your IDE, nobody really cares about them. Well, TypeScript is like putting type hints on JavaScript, but everything goes to flame if there is any typing problem in your code. Since we are already deep into front-end code, might as well show you how it works. I took my breath and cloned the React template for Streamlit Component. Move the template, my component folder, outside the cloned repo. Rename it, then delete that repo. There's a package JSON inside. You know what to do when you find one. You npm install it, it immediately gets the dependencies. Then I add React Plotly and the associated TypeScript types for Plotly objects. Notice the index.html file is now inside a public folder, and there's a new bootstrap CSS file that resets some CSS properties. I don't need to touch those. The entry point is now index.tsx, the extension for a React TypeScript file. It embeds a my component import. I rename it to Plotly events to be clearer. Remove all code in the Plotly events file and create a new functional component Plotly events that takes as input a Streamlit event. This should return a React object that will automatically be injected inside the index.html file. First, I import a plot object from React Plotly, parse the specifications from the args object coming from Python, and use this as properties of the Plotly plots. This function, like in the previous steps, is called at initialization or whenever the input arguments on the Python side change. The Streamlit hook initialization part is taken care of by the with Streamlit connection higher order component. Finally, I redefine the component's height after the component was mounted in HTML using a specific React hook called useEffect, which runs as a side effect on the height after everything else. Oh, I need to handle the click event. When I hover the React Plotly plot object, I notice a new onClick prop there. Yeah, the Plotly React API is a little bit different from its vanilla JavaScript counterpart. JS events are mapped to props instead of being declared with a method. Create a new handleClick arrow method, which takes as input event data from Plotly. This is where TypeScript becomes more important because because it requires me to explicitly type the input argument. Yeah, granted, if I'm as lazy as a lazy developer, I can just put any, but I want my IDE to stop crying at how bad my coding abilities are. Let's hover on the on-click prop and take note of the types required. Type the input as a plot mouse event, and now I have a better idea of the object I'm manipulating, and it's kinda cool because I know I can access the points property. So I just map through each plot datum to fetch the x and y coordinates. Then as always, I set this as the result from a component value. If you keep building on this base, you should be able to build your own Streamlit component the way I did for streamlit-echarts, streamlit-drawable-canvas and streamlit-lottie that you can go read as examples. If you're actually a web developer that wants to contribute components to Streamlit to help other fellow data scientists, but you prefer using Vue.js or Svelte or etc., there are templates that integrate the Streamlit JavaScript initialization hooks into the specific framework construct. So you're actually free to use any JavaScript framework. And when I look back at my work from 8 years ago, I think to myself, that front-end web app I did in a week, I could now do it in 1 hour with the Streamlit components. So dare to take the plunge into this smaller scope of JavaScript, you'll be able to build things that no other data scientist could, and that is what gets your data science noticed. Hi there, future editor Fanil. I just finished editing the tutorial. Look, here it is. It took me way too much time. So if you've watched the video this far, thank you very much. It means a lot and it helps the channel a lot. So I'm going to do something I'm not supposed to do, which is multiple call to actions. If you want to support the channel even more, don't forget to like and subscribe and leave a comment and even buy me a coffee. It helps staying awake while editing the tutorial so I can do more of those. Thanks again for sticking with me. Stay safe. Bye.